So today we're going to be looking at tree diagrams. Okay, now these are structured a bit like the frequency trees that we did a couple of lessons ago, but these are going to be more focused on probabilities rather than numbers, which is what we were looking at when we were doing frequency trees. Tree diagrams help us work out the probability of two events occurring or not occurring, or up to even three events if it's going to be a more challenging question. If it has three events, then that's going to be a bit more of your grade 8 and 9 style questions. The rest of the stuff is really around grade 6, grade 7, depending on how tricky it wants to be. We are going to start today by looking at the easy ones, and in tomorrow's lesson we're going to look at some of the challenging ones where more things vary and we have to be very careful about where we are labeling certain numbers. So here's a very typical question. It says the probability of rain on any given day is 0.3. Draw a tree diagram and use it to find the probability of it raining or not raining on 2 consecutive days. Now again, if it's going to be a nice question, then maybe we'll have even drawn your tree diagram out for you. But I want us to try and do everything from scratch because there is a chance in an exam this is the type of question you'll get. There'll be no diagram to help you with, and it's just you have to go and do it yourself. So we need to set this up where on one day it's either going to rain or not rain, and then on the second day it's going to rain or not rain. Now the key thing that we're going to be looking at on today's tree diagrams is the second day is not affected at all by whatever happens on the first day. So if it rains on day 1, that doesn't increase or decrease the likelihood of it raining on day 2. In tomorrow's lesson we are going to be looking at, well, what would happen if it raining on the first day? Would that mean there's a better chance of it raining on day 2 or a lower chance? But we'll get onto that tomorrow. So we're going to start off then with a point down here, like this. So this is our starting point, and on day 1 what could happen is it could either rain or not rain, and I'm going to show not rain by our dash. We have covered this before, but a little dash means not that event. So R stands for rain and R dash means not rain. Now we put the events, the things that are happening, at the end of the branches. And we put their probabilities on the branch as we go along. So the probability of it raining is 0.3, so I'm going to put that up here. So that means the probability that it doesn't rain must be 0.7. Okay, each section of a branch, they should always add up to 1, because it either rains or it doesn't rain. There's nothing else that could actually happen. And this here is day 1 complete. There's nothing else that can happen on day 1. So now let's look at what happens on day 2. So we're going to have to do this twice. We're going to have to first of all assume that it has rained on day 1. If it rains on day 1, then on day 2 it could still rain, or it might not rain. Now these probabilities are not affected by the previous one, so it's still a 0.3 chance of it raining and a 0.7 chance of it not raining. And again, because these questions that we're going to do today are the easy ones, it's going to be the same at the lower half of the diagram as well. If it did not rain on day 1, then it still has a chance of raining on day 2 or not raining on day 2, and those probabilities are exactly the same. So that's our tree diagram drawn. The green bit shows day 1, the red parts show day 2. And now we need to use these in order to work out all the different possible combinations. Now this isn't something you have to do every time, but it's something I like to do because there's always a good chance there's a part B and a part C to these questions. And if we've spent 10 seconds working out some numbers, it makes the next part really, really easy. So all I'm going to do is for each possible branch combination, I'm going to multiply those probabilities, and that will give me the joint probability of that thing actually happening. Sounds a bit complicated, but it's not. So for example, if I want it to rain and rain, That's this part of the diagram here. It rained on day 1 and then it rained on day 2. So I'm going to write this as RR, rain and rain. And the probability of it raining and raining is 0.3 times by 0.3. Which I can do in my head is 0.09. So there's a 0.09 chance of it raining on 2 days in a row. The next one I'm going to do is rain followed by no rain. So it rains on the first day and then doesn't rain on the second day. So I'm going to write this as rain, not rain. And again, I'm just going to times the 0.3 by the 0.7. And that gets me 0.21. The next one would be no rain followed by rain. So this is 0.7 times 0.3. And the last one is no rain and no rain, which gets me 0.49. And now you can always check that these numbers are correct because these numbers here should always add up to 1 because they're the only combinations of things that can happen. Okay, so what I was doing is if I'm trying to use the word and in these tree diagrams, I'm going to be thinking about multiplying those probabilities. If I wanted rain and rain, I've done 0.3 times 0.3. There is another word I'm going to be using in a few minutes' time, which is the word or. And if I use the word or, I'm going to be adding those probabilities together at the end. Okay, we'll get to that when we do the second question, which is right here. So it says, Jake and Alfie are ordering food at a burger restaurant. The probability that Jake picks a chicken burger is 0.2. The probability Alfie picks a chicken burger is 0.6. Show this on a tree diagram. So again, it doesn't matter which person we start off with here. The key thing here is one of them does not influence the probability of the next person picking a chicken burger. Okay, if Jake picks a chicken burger, that is not going to increase Alfie's probability of getting a chicken burger as well. Maybe it wouldn't happen in real life, but for this question, we're going to stick with it. So I'm going to do it in the order of the question. So I will start off with Jake. I'll make it a little red dot there. So Jake is either going to buy a chicken burger or he's going to order something completely different. No chicken burger. The probability he gets the chicken burger is 0.2. So the probability he doesn't get the chicken burger is 0.8. Again, those probabilities have to add up to 1. Then we'll look at Alfie. So if Jake buys the chicken burger, Alfie could still get a chicken burger, or he might not get the chicken burger. His probability of getting the chicken burger is 0.6, so he's got a 0.4 chance of picking something else. That is exactly the same, even if Jake didn't go for it himself. So the probabilities here on the second section of the branches, they're not getting affected by whatever happens at the beginning. So now I could work them out. I'm just going to change them quickly to just C. It's going to save me a bit of time. So the probability they both buy chicken burgers is 0.2 times 0.6, which is 0.12. Or chicken, and then not chicken, it's going to be 0.08. Okay, just remember at this point here, these two numbers actually add up to this number here. This is not a chicken burger, but the second person buys one, so if I times them together, I get 0.48, and the last one is they both don't buy chicken burgers, which is 0.32. And again, look, these two numbers here, they both add together to get that first branch. That's just something that will always happen. So there's my tree diagram done. That can actually be worth 2 or 3 marks in an exam, depending on how nice they want the question to be. And then we've got these questions over here that we're going to quickly answer. Hopefully they're not going to take too long because I've already written out these numbers over here, which I can now hopefully just use super fast. First one then says, what is the probability that they buy together 2 chicken burgers? So we want the chicken burger followed by the chicken burger. We've worked out that probability. That one's going to be 0.12. That one's done. Now the next one says only 1 chicken burger, but it doesn't say which of them has to buy the chicken burger. So what I might want is I might want Jake to buy the chicken burger, which would mean Alfie does not buy the chicken burger. That's got a 0.08 chance of happening. So that was Jake and not Alfie. That's why I went 0.2 times by 0.4. Or there's a second option, which is Jake doesn't buy it, but Alfie does, which is this 0.48 number. So the key thing I said halfway through there was the word or, which means I want these 2 probabilities added together. They both get me just 1 chicken burger, but there's 2 different ways of doing it. So I take their individual probabilities and I add them together. So I'm going to do 0.08 add 0.46, and that's going to get me 0.56. The next question then says at least 1 chicken burger. So that means one of them could buy a chicken burger or both of them could buy a chicken burger. So this top one, there's at least 1 chicken there, so this is a good one. This one, there's at least 1 chicken, so that's a good one. Here, there's only 1 chicken burger, that's fine. In fact, the only one I don't want is this bottom one. This one here does not get me at least 1 chicken burger. So I could answer this question in one of 2 different ways. I could either add these 3 probabilities together, as they all get me at least 1 chicken burger. Or if I know they all add up to 1, and this is the only one I don't want, I could do 1 minus 0.32. Whichever way I decide I'm going to do it, I will get an answer of 0.68. So these are the types of questions that are on the worksheet that's also been attached. It's either going to be one of these questions like we did at the beginning where it's the same probability on 2 different events, or there's going to be, is it going to change? There it is. Or it's going to be 2 different probabilities, but the probabilities are fixed. Okay, so the first thing does not affect the second thing at all. This, by the way, this question here, it wouldn't have mattered to the final probabilities over here if I had done it with Alfie as the first branch and Jake as the second one. So don't get confused when you read some of the questions about trying to work out who goes first and who goes second, because this probability here would still have been a 0.6 times by a 0.2. The order of these might have been slightly different. Maybe these 2 here may have gone the other way around. But it wouldn't matter if you put Jake first or Alfie first. Again, I've tried to include the answers for this on Show My Homework so you can check them as you go along. You don't need to send me any work because the answers are there. What I wouldn't mind though perhaps is maybe just a little sentence about how you found today's questions. Just say things like, I was fine, it was quite easy, got 100%. Anything along those lines is fine. You don't need to send me the actual work, but you just need to send me a little comment. In tomorrow's lesson, we're going to kind of look at these again, but as I've kind of already alluded to, the second probability branches are going to be affected about what's already happened. Okay, so it might be things like if you've got a tin of biscuits, the moment you take 1 biscuit out, the second probability is no longer going to be the same as what it was at the beginning, because there's 1 less in the actual tub. But we'll look at those tomorrow. So give the questions a try. Drop me a message on Show My Homework to tell me how you found today's work, and I will see you all tomorrow.